Hey, welcome to the Unit 7 test review here. We're not going to cover everything on this Unit 7 review. It would go quite long. So you might want to, on your own, look at the consecutive integer problems, maybe a coin problem, and a rectangle, triangle, side length thing there. We'll cover a majority of the rest, though. And let's get started right away. So here we go. Remember that you may have to simplify expressions on both sides of an equation or inequality as your first step. So here's an example of that. Notice that we've got a couple of variables here and something we can clean up here. Of course, if we add those two together, we should end up with this. And from this point forward, we can easily solve for m. So let's look at this one now. Notice you've got x's on the left and a constant on the right. Let's go ahead and clean up that left-hand side. 8 and negative 5x, of course, give us a nice, easy 3x minus 1 equals 5. Very quick linear equation. Go ahead and get rid of what's farthest away from x. And again, the inverse operation of multiplying by 3 is to divide by 3. We're always doing the inverse operation to isolate variables here. Divide by 3, and we end up with x equaling 2. Good. And if you take this 2 and plug it in here, we get 16 minus 1 minus 10. So that would be 15 minus 10 does indeed equal 5. Okay, so that's where that little backup and proof comes from. All right, how about this one? So what are we going to do first here? Well, you've got 5 times the quantity p minus 2 equals negative 15. So on this one here, why don't you go ahead and try this one on your own? We've done quite a few of these, and let's see how you do in a minute. All right then, did you start by distributing? So if you distribute twice for the binomial, we end up with that on the left equaling negative 15. Again, get rid of what's farthest away from that variable there. And let's go ahead and add 10 to both sides. And this gives us 5p equaling negative 5. Divide both sides by positive 5, and you should have ended up with p equals negative 1. Again, if you take this negative 1 and plug it in, negative 1 subtract 2, that's negative 3. 5 times negative 3 is indeed negative 15. So, very good. Left side equals right side. All right, still from Unit 7-2, a little bit more of a challenge here. What do we do here? We've got a d out front, and we've got this. Now, of course, we can't add these because they're not like terms, but even if we could, we would not. Order of operations, we're going to multiply first, okay? So ignore this guy out here. Let's distribute first, see what happens. Give that a try, and I'll be right back with you. All right then. How about this? Distribute, and we end up with d plus 3d minus 12 equals 20. Okay? Combine those letters d, 1d plus 3d, and this is going to be the result of combining like terms. And now get rid of what is farthest away from d there, so let's add 12 to both sides. And divide by 4, of course. So hopefully you got your answer of 8. Well done, 8. And of course, if you substitute an 8 here and an 8 here, well, we get 8 plus 3 times 4. Well, we know that 8 plus 12 is indeed 20. Good. All right, so now make sure that we watch for all of our signs. And in Unit 7-3, we saw a reinforcement of our love note rule. Our love note rule here, this negative sign negates everything inside the parentheses here. So this positive 2y becomes negative 2y. The positive 4 becomes negative 4. And then we get to work. Okay? So watch that negative sign. And here we go. Remember, see how this positive 2y becomes this, and this becomes negative. Now let's combine like terms. Okay? All right then. Your turn here. Why don't you give this one a run and see what you got. All right then, did you apply that negative to both the x and the positive 2? So hopefully you end up with this. This is the result of the negative outside the parentheses. 6 and negative 2 should work well together, so let's go ahead and get rid of those. And now, go ahead and let's get rid of that 4, okay? Because we want to get that x by itself. This is going to leave us with negative x equaling 5. Now that's not what we want. We really don't want negative x or the opposite of x. We want positive x or 1x. So how do we get rid of that negative 1 hiding here? Well, we can divide by -1 to both sides to make the variable positive, okay? Which of course is going to change our constant to x equals -5. Good. Alright then. Let's see. Take a look at this one here. You've got, what do we have now? We have letters on both sides of the equation, and we're going to look for the smaller value here. That's the best thing to do in most cases, especially with inequalities. Alright, so here we go. Let's go ahead and get rid of that 4k. When we do so, we end up with 3k equals 15. We know that 3 times k, 3 times something is 15. Well, we know by now, of course, that's 5. Alright. Again, whatever you do to one side, please do to both sides of any equation or inequality. Give this one a try here, and we'll check in with you in just a second. Okay, did you get rid of the 3x? Hopefully so, which leaves you with 2x minus 2 equals 8. What's next? Add 2 to both sides. Okay, we do so. Very good. And finally, that's right, divide both sides by 2. And we are done. X equals 5. Plug a 5 in here. This would be 25 minus 2 is 23. 15 plus 8 is also 23. Good. How about this guy? 2 times the quantity y plus 6 equals 3y. Go ahead and we're going to deal with the distribution first here. So let's distribute that 2 through, and we end up with 2y plus 6 equals 3y. Which is smaller, 2y or 3y? Well, obviously 2y is, so let's get rid of our 2y there from both sides. And our final result, y equals 12. Y equals 12. And just a little reminder here, read from the letter, okay? Read from the letter. I know with an equation it's pretty obvious, but it'll help you with inequalities if you go forward by just reading from the letter. Left to right, right to left, top, bottom, up, down. Doesn't matter. Read from the letter. Alright, now when we're working with inequalities, make sure we watch for the opportunity and the requirement to flip the inequality sign, okay? So in this case, 8 minus 3y is greater than or equal to 68. So we get rid of what's farthest away from y first. Let's go ahead and subtract 8 from both sides. And that leaves us with negative 3y is greater than or equal to 60. To get y alone, we're going to divide both sides by negative 3. And when we divide by negative, what's our requirement now? Well, first of all, to do our math correctly. But next, of course, we have to flip the inequality over. Okay, flip the inequality because we divided by negative. It doesn't matter that the answer is negative. That's irrelevant. It's the operation. This piece here is negative. Then we turn the inequality. All right, give this one a try on your own, and let's see how you do. All right, getting rid of what's farthest away from x. Did you subtract 6 first? Okay, so this leaves us with 3x is less than or equal to negative 18. Divide both sides by what number? By 3, correct? By 3. Is that a positive or negative 3? Well, it's a positive 3, so we're not worried about messing with the inequality. Just leave it alone. X is less than or equal to negative 6. So any value of x that's less than or equal to negative 6 will make this a true statement. Negative 7, negative 700, negative 10, negative 6.1. Anything that's 6 or less, even negative 6 would work here, to make it smaller or equal to that number there. Oh dear. Okay. How about some rational equations here? We studied these in Unit 7.7. So go ahead and watch this one. I'll kind of remind us how we did. We have a fraction basically set equal to a fraction. Or in algebra, we call these rational expressions set equal to rational expression. Remember, we crossed multiplied. Be careful now. We did talk about looking for exclusions. We cannot let the denominator be equal to 0. So we can't let this, of course, what would make this 0? Well, it seems pretty obvious that 2 would make that 0. What would make this 0? The number is 0. So if we get 2 or 0, we'll have to go back and look at our problem again. Let's go ahead and cross multiply here. 5 times x and 3 times the quantity x minus 2 looks like this. Distribute that 3 through, and we end up with 3x minus 6 equals 5, which is the smaller version of x. Well, of course, it's 3. Subtract that 3x from both sides, divide by 2, and x equals negative 3. So it doesn't look like negative 3 is going to bother us. We can have negative 3 down here. That would give us negative 1. We can have negative 3 here. Again, that would give us 5 divided by negative 5 is negative 1. So it's going to be just fine. All right. Why don't you go ahead and give this one a try. I've got 2 more of these for you to look at. So if you feel like it, just press the pause button, give it a try, and we'll check your answer here in just a second. Okay, did you start by looking at the exclusion? Of course, we can't let n be 0 because 1 over 0 would make this 0. And also, what would make this 0? How about negative 4? So if our answer is going to turn out to be 0 or negative 4, let's just keep that kind of in the back of our mind. Let's cross multiply here. So n times 3 and 1 times anything is the identity property. So we know it's going to be n plus 4. That's fine. Makes things a little bit easier. So 3n equals n plus 4. Get rid of the smaller version of n by subtracting n from both sides, and n equals 2. So if we plug a 2 in here, we get 1/2. 1 over 2, that works. And 2 plus 4 is 6. Isn't 3 over 6 equal to 1 over 2? So 2 is a perfectly good answer. We don't have to think about exclusions here at all. And why don't you try this one as well. 4 over h plus 1 equals 2 over h. You tell me, what do you think this exclusion, what would make this guy here 0? That's right, negative 1 would make this 0. What about this? Now, negative 1 here is fine, but what's a number we can't have here? Well, 0. So keep that in the back of your mind. 0, negative 1 might cause us an issue, okay? Well, actually, it would cause us an issue, but we'll see what that looks like when you get to the end of your answer. Okay, did you cross multiply? 2 times the quantity h plus 1 equals 4h. Equals 4h. So set those up, set equal to each other. Distribute that number 2 through there, and we get 2 times the quantity h plus 1 is, of course, 2h plus 2. Get rid of the smaller value of h, and that sets us up with a nice, easy equation. 2h equals 2. Divide both sides, and there you got h equals 1. And of course, h can be 1 all day long, because what's 2 divided by 1? Well, that's 2. What's 1 plus 1? Well, that's 2. Neither one of those are 0 in the denominator. And so 4 over 2 and 2 over 1 are equivalent. Now, you're not going to have to worry about excluded values on the test. That is more for your long-term learning for geometry, algebra 2, and so on. Remember, excluded values will appear on occasion, and you've got to watch for those. No dividing by 0. All right, let's look at a work problem where we're going to combine 2 workers here. So we have a painter that can paint the house in 10 hours and a painter that can paint the house in 6 hours. Let's say we have them work together here and speed things along. Remember what we said, let's let them start and then come back an hour later, and how much of the work would be done? So wouldn't 1/10 of the house be done after 1 hour? But if we let the second painter get started, 1/6 of the house would be done if he was working alone. So together, let's combine their efforts here. So 1 over 10h plus 1 over 6h equals 1 house painted. Now looking at the denominator, 10 and 6, can we combine those somehow? Think back to how we get a common denominator. I'm thinking the number, what are you thinking? I think we're thinking the same thing. 30, that's correct, 30. Change those numerators. And now we have a common denominator that we can add up. So clean up the numerators, and we're looking at 3 over 30h plus 5 over 30h equals 1. Simplify that left-hand side. Did you get 8 over 30h? Now remember, what's our magic trick to make any fraction disappear? It is to multiply by the reciprocal. So the reciprocal of 8 over 30 is 30 over 8. Now h is isolated because we're talking about how long, time, hours, it'll take them to paint the house. 30 over 8 is a nice math answer, but for a word problem, make it an answer that someone can understand. So how about 3.75 hours or 3 hours 45 minutes? That's a nice fast job time to get your house painted, I think. All right, that's it for our review. Please, if you can, fill out that note card, bring it in. You can bring anything you want on it for the test, turn it in at the end there. The review video is designed to help you study, but all items covered during the Unit 7 test are fair game for the test, whether the items appear in this review or not. Okay, so I couldn't really cover every single little nook and cranny of the test, but take a look at some of that stuff we've studied. Things that aren't here won't be hit really hard, but they may appear on there for you. At the end of each unit video, there is a web address for some digital practice for you. So if you want to go back and look at the video, the units that we looked at, you can look at the end and do some digital practice.